inequalities. What are the types of linear inequalities we have? You've done inequalities before. There are 4 types. What kinds?
Greater than.
Yes, greater than, less than or equal to, and greater than or equal to. There are 4 types of linear inequalities, okay? And you have less than, you have less than or equal to, you have greater than, and you have greater than or equal to, okay? And they always come in the form ax plus by is whatever to c, to your constant, okay? An ordered pair, x, y, is a solution of a linear inequality in 2 variables. If the inequality is true, the values of x and y are substituted into these inequalities. So what they're going to do is they're going to give you linear inequalities first to start with, and they're going to say, tell me which ordered pair fits this statement. So I'm going to put 4 ordered pairs on the board, and you're going to tell me which ordered pair works in that statement. The first one is 6, negative 3. Second one is 0, 2. The third one is negative 3, 5. And the fourth one is negative 2, negative 1. What set of coordinates makes that statement up above true? How can I figure it out? Plug it in. What do you want to start with?
C.
You want to start with A, Tyler? Okay, we'll start with A.
Why does it say A, B, C, 4?
Because I'm stupid and I was counting and doing numbers at the same time.
Silly views.
Silly me. Okay. A, B, C, D. How's that? Does that help? Okay. So Tyler, we want to plug 6 into X. So what's 3 times 6? And what is negative 3 times 4? What is 18 minus 12? 18 minus 12, 6. Is 6 greater than 8? No, so this doesn't work. What do we want to try now? I told you start with C. C? Okay. 3 times 3, or negative 3 times 3 is?
Negative 9.
And 5 times 4 is? 20. So you have negative 9 plus 20 is greater than 8. What's negative 9 plus 20? 11 is greater than 8. Is that true?
Yeah.
So this is my solution, my ordered pair. Okay? Can you handle that part of inequalities? Can we handle plugging and checking? Okay. From there, we're going to go into graphing. Yeah, oh good. You guys should have graphed with Mrs. McCain in the past, linear inequalities, or at least been introduced to it, okay? So some things we need to take a look at when we graph linear inequalities. The graph of a linear inequality in 2 variables is the set of all points in a coordinate plane that represents solutions of that inequality, which means we have to shade. Just like when you do a number line, yes? Like if we had y is less than negative 2. Okay, you would have your number line, right? 0, 1, negative 1, negative 2. And you'd come to negative 2 and you'd put a parenthesis and you would shade that way. Because that's what would make this statement correct, yes? Yeah. Remember those? Okay. So we are going to do this, but we're going to do this with graphing. Okay? So here they give you an equation. 3x minus negative 2 or minus 2y is greater than 2. And they said, here's the graph of it. Okay? And the boundary line, this dotted line, divides the plane into 2 half planes. The shaded half is everything that's a solution of that equation. Okay. Can I graph from this form right here, 3x minus 2y is greater than 2?
No.
No, I could. It'd be very difficult, but no, not really. What do I need to do to that to graph it? Kind of.
Plug a point in.
I could plug points in and do that.
Y equals mx plus b.
Okay, if I get it into a linear form of y equals mx plus b, then I can graph it easier. So if I have this equation of 3x minus 2y is greater than 2, what am I gonna do to get y by itself?
Minus 3x divided by -2.
Yes, minus 3x, which gives me negative 2y, is greater than negative 3x plus 2. When you divide by a negative 2 on an inequality, what happens? The thingy flips, yes, the sign flips, okay? So I'm going to end up getting y is less than 3 seconds x minus 1. Now, I can graph that up here. Does that make sense? Okay, why is there a dashed line on this graph?
I don't remember, but we did it in the
Greater than.
Because it's greater than,
Yeah.
or when else do I use a dashed line?
Less.
Less than. When do I use a solid line?
when it's greater and equal.
When it's greater than or equal to. Good. Okay. So when we go to graph a linear equality, there are 2 steps we're going to follow. First, you're going to graph the boundary line. Okay? And the boundary line for the inequality, you're going to use dashed line for greater than or equal to. Okay? What we just talked about. And you're going to use a solid line for less than or equal to and greater than or equal to. Step 2, you're going to have a test point. Okay? Your test point is a point not on the boundary line, which means if for them to figure out how to shape this, they chose a number, a set of points, a data point that wasn't on this line. I were you, if 0, 0 is not through the line, I would use that every time because it's easy. We can all work with the number 0 pretty easily, okay? So they plugged in, let's say they plugged in 0, 0. If they plugged in 0, 0 to this statement, they said 0 is less than 3 seconds times 0 minus 1. Is 0 less than negative 1? Is 0 less than negative 1? No. So they did not shade where 0 was. They shaded against it. Okay? We good with that? Okay, so we're gonna graph 4 different ones here. We're gonna practice, yes. Oh, good. Cool. We're gonna pretend that all this stuff is true. Okay. Practicing, practicing, practicing. Let's do this. How would I graph? Let's graph first. Y is less than or equal to negative 3. How would I graph that? What do I need to do?
Put your on negative 3.
At negative 3 on where?
Y-axis, the Y.
On the y-axis. Negative 3 on the y-axis, okay. And then what?
And then you
Graph
draw a
everything.
solid line.
I draw a solid line because it says less than or equal to. So I draw a solid line horizontally.
You put
And then you
everything
shade
below.
everything
Below.
Okay, I'm going to shade, but I want you to show me your work about shading. So I'm going to plug in 0 to y and see if that statement is true. Is 0 less than or equal to negative 3?
No.
No, so that means I have to shade below this line. So on your homework, you can use different colors. Feel free to do whatever you want there with pencils or highlighters or whatever. Okay, let's graph this one. How do I graph x is less than 2?
You're gonna put your point
on the x-axis.
X-axis this time. That means my line goes
up and down.
up and down.
Yeah.
Dashed or solid?
Yeah.
Dashed. Okay. Dash in this line.
Plug 0 in for x.
Good, I like it. Let's put 0 in. Is 0 less than 2?
Yes, ma'am.
Yes, so then I shade everything that's where 0 is. It's beautiful, isn't it? Okay, now we're gonna go with some other ones that have multi-steps. Oops. Okay, let's see if we can do this. This one's gonna be a little bit more complicated. Okay, let's try this one. Let's start with, we'll do this one in black. Let's do y is greater than negative 2x. How do I graph y is greater than negative 2x? Where's the y-intercept?
Y-intercept
This
one.
way, this way.
No, isn't it on the right?
0.
Why is the y-intercept 0, Maddie?
Because if hi
Hi,
Tyler. If y equals mx plus b, there's no b.
There's no b, right, there's no y-intercept, so it's 0. So my y-intercept is 0. That means my slope is what on this one? -2. So it's a rise of 2 and a run of 1. So down 2 over 1, down 2 over 1. Down 2 over 1, there's a point here, and I could reverse it so that I can see it right here. Dotted or solid line?
Dotted.
Dotted, because it is greater than. Dotted line. Okay, I got my dotted line. Now what do I do?
You shade.
Where? How do I know?
You zero in the
I can't plug 0 in. 0's on my line this time.
Oh, just kidding. Don't do that.
What do you
Shade
want to
on the
plug in?
left.
Plug 1 and 1.
Plug 1 in? Okay, plug 1 in 1. 1 is greater than -2 times 1. Is 1 greater than -2?
No.
Yes.
I mean, yeah.
So 1 is a true statement to it, so I shape it this way. Okay, next one. 5x minus 2y is less than or equal to -4. What do I need to do first?
Put it
Put
in
it
slope
in
intercept.
Put it in slope intercept form. Ugh, can't talk. 5x minus 2y, I'm gonna start it up here so that I can have room. Minus 2y is less than or equal to -4. What do I do first?
You subtract the 5x.
Subtract 5x from both sides, good. So that you get -2y is less than or equal to -5x minus 4. Now what?
You divide by -2.
Okay, what happens when I divide by negative?
You flip this
Don't
side.
forget to flip it. So now it says y is greater than or equal to 5 seconds x plus 2. Now I can graph this, yes?
Yes.
Okay, so where's my intercept?
Two.
2. So I start at +2.
Yes.
Okay, then what?
You
Then you
Up
go
2
slope.
and
You
then
go
up
up
5
up
over 2.
Up 5 and
over
down and over 2. So we're
Yeah.
going to pretend that I have 5 lines here. 1, 2, 3, 4, 5. And then I'm going over 1, 2.
Perfect.
Okay? Dashed or solid?
Solid.
Solid. Okay. Now what are we plugging in? Can you plug
6. Uno.
I can plug in
0.
what this time? 0, because it's easy. So I plug in 0 greater than or equal to 5 seconds times 0 plus 2. So is 0 greater than or equal to 2?
No.
No, so I cannot shade where 0 is. That means I do not shade below. I shade okie dokie.
Artichoke.
Questions on any of that so far?
So if 0 is not greater than it, then you can't shade where 0 is.
Right, if the statement is false, you don't shade where that number is that you plugged in. You shade it against it. Okay. Any other questions? Nothing else?
No.
We're gonna stop there today.
Okay.
Yeah.
We still got 20 minutes.
That's all you did.
20?